Kafka is on every senior platform engineering job spec in 2026. Half the teams using it shouldn't be. But let me show you which side of that line you're on. Kafka is a distributed log. Simply, that's the technical answer. Keep that sentence in your head and the rest of Kafka just makes sense. 3 concepts I want to address in what I just said. Number 1, it's a log. That means it's essentially an append-only list of events. New stuff goes to the end. Nothing in the middle ever changes. Now think of a supermarket conveyor belt. Items going at one end. The belt remembers everything that's been on it. Anyone standing along the belt can read what's there. Number 2, it's distributed. That means the log is split across multiple machines so it can scale horizontally. So that means each split of that, right, is called a partition. More partitions means more throughput, much faster, right? That's how Kafka can handle hundreds of thousands of messages a second without flinching. Number 3, it pops up on top essentially, right? That means anyone can write to the logs. Anyone can also read from it. Also, multiple consumers reading the same data independently, each at their own pace. Then you have producers, which essentially writes topics. Now topics are partitions across brokers. Consumers read from topics. Now tracking their position with something called an offset. Each message has an offset ID, right? You have topic, partition, producer, consumer, offset. These are the 5 things. That's what Kafka is. Now, why is it suddenly everywhere? Look, Kafka has been around since 2011, before AI came out. LinkedIn have built it. So why does it feel like everyone needs to have Kafka in 2026? And mainly 4 reasons I'll go through with you. The first reason, look, AI changed what real time means. AI agents need event triggers, not just polling loops and stuff like that. Let's say a user submits a form, an event is fired, an agent picks it up. It runs your inferences and it fires another event downstream. Now that whole pattern is event driven by default in 2026, and Kafka is the spine of it. Second reason, microservices over time got very complex and really complicated, right? Now once you're past more than 10, 15 services and you have point-to-point HTTP between them, that turns into a dependency graph that is very hard to manage. Putting Kafka in the middle of that, it means service A, it can drop an event at a topic and you can walk away. Now whoever actually cares about that event can pick it up. So service A doesn't know or care who's consuming it. That's why it's cool, and that's why it's important to have this concept called decoupling. And that scale is the difference between something actually failing and being a success. Third reason, data warehouses are taking over streaming. ClickHouse, Snowflake, BigQuery, all of those, they want a constant stream of events from your transactional databases. And this pattern is called CDC, Change Data Capture. Tools like Davidium, they read your Postgres write-ahead log and they push every change onto a Kafka topic, and also downstream consumers pick it up near real time. That pipeline used to be a nightly batch job, but now in 2026, half the data engineering specs you read are some form of flavor of this basically. Reason 4, compliance and replay. Because look, Kafka, like I said, is a log, not necessarily a queue. The events stick around, right? You can replay them. 6 months later, when something broke and you need to know why, you can go back to the topic and rerun the events. Fintech, health tech, anything regulated, this is golden for them. Now, it's also the bit that makes engineers look at Kafka and go, oh, this is just a queue with basic retention. And then immediately that's it. That's what Kafka is. Those are your 4 reasons. AI and real-time, microservice decoupling, change data capture, and order and replay. Any one of these is enough to put Kafka on a senior job spec. In 2026, most companies have at least 2 of them. And here are 2 use cases where Kafka is so important. First one, event-sourced systems. Trading platforms, fintech ledgers, e-commerce, checkout flows, all this stuff. Anywhere the order of events is a source of truth, and you need to reconstruct that state by replaying the log, Kafka is the immediate and natural fit. That's what Kafka basically is. Look, I run event-driven infrastructure in various organizations, and the replay of part of that isn't just a nice to have, it's the audit trail. Secondly, the fact that it has high throughput log aggregation, and it can process streams as well, right? And hundreds of thousands of events per second. Multi-consumers, each doing different process on the same file host. Real-time analytics, dashboards, fraud detection, observability backends. RabbitMQ, falls over here, right? SQS gets really expensive fast. Kafka is made for this. If your use case fits one of these 2 things, Kafka is most likely the right call, and you should learn it properly in 2026. I've shipped event-driven systems on Kafka, NATS, RabbitMQ, SQS at different places. Now the pattern's always the same. The reason why teams pick Kafka is because it wasn't just on a blog post. It's because someone senior had used it at their previous places, or because the architecture diagram probably looked more impressive with it. So then they spend 6 months learning how to plan their partitions, tuning the retention, rebalancing consumer groups, and so on. Now, there are some cases where you won't need Kafka, and I'll go through them with you. The first one is, let's say we have fewer than maybe 1,000 messages a second, and you don't need things like replays and stuff. RabbitMQ or NATS could run on that on a small box, and you don't have to worry about it. Secondly, if you want to stick to AWS services, native AWS, and you're a small team, you haven't got much budget, maybe SQS plus SNS might do the job for you, where you don't have to even manage servers. Thirdly, if you have a mechanism that is like request response and is not event driven, so like for example, service A needs an answer back from service B immediately, that's an HTTP call, right? Or gRPC, for example, not something that Kafka can do. Putting Kafka between them would add some sort of latency. Fourthly, you can't say in one sentence how long events should live. If, for example, I say, how long do we keep these things, and that people don't know the answer to that, then you don't really need Kafka. My honest take is that, look, use NATS for low latency and lightweight pub sub mechanism, especially microservices. Maybe use RabbitMQ for traditional task queues that has priorities and acts. If you want AWS native, stick with SQS. If you want service request responses, use plain HTTP. Use only Kafka when one of these 4 reasons we covered doesn't apply to you. If you do pick Kafka, here's the reality behind it. It can cause some sort of operational complexity, right? We know Kraft replaced Zookeeper in Kafka at 3.8 or 9, which essentially simplified the cluster, but the partition planning, the consumer group management, and the retention tuning are still part of the price. So you spend time with these. There's no Kafka without them. If you take one thing from this, know that Kafka is a distributed log. Topics, partitions, consumer groups, that's the 4 reasons, it's everywhere. All of it is downstream of that. If you get this log model right, then Kafka makes much more sense. If you're interested to get much deeper knowledge of Kafka, join our free DevOps community where we'll teach you how this works.